So hope you all had a good spring break. As Greg mentioned, we'll return the midterms later this week. So let's get started. So in the second half of this class, post-break, we're going to cover kind of a broader range of topics, starting today with issues in health and health economics, turning to other things like environment, crime, and so forth, just to give you a broader flavor of the various things that people are doing in social science using big data. So starting with health outcomes in this lecture and the next couple of lectures. So as you've seen in the first half of this class, research in economics typically focuses on earnings or wealth as the key outcomes of interest. So we spent a lot of time focusing on income mobility, income inequality, and so forth. But as you all know, a lot of people view health and life expectancy as among the most important aspects of well-being. So we spend a lot of time measuring earnings, but I think people care about a lot of things beyond earnings, obviously, and one of the prime things, I think, is health. And so at a broad level, the kind of question people are focused on in this area and what we're going to talk about in this lecture and subsequent lectures is what interventions are most effective in improving health, kind of holding fixed the current frontier of medical technology. So if you think about health from a different dimension, of course, there's a tremendous amount of research in the natural sciences on trying to improve health by actually improving medical technology. In the social sciences, I think the way we think about it is taking as given the set of drugs we have, the set of technologies we have, what can we do in terms of the way we set up systems, public health, health insurance, food stamps programs, things like that, to try to maximize population health. That's the type of question we are focused on. Now, research on these issues is not just within economics, but spans many, many fields, from epidemiology to public health to economics to various social science fields that are focused on health inequality, changes in health over time, and so on. So what I'm going to do in this part of the class is give you kind of a sampling of what that type of research looks like, illustrating how big data is helping us learn how to improve health in 3 segments. So first, I'll start today with just a descriptive analysis of health outcomes in the US population, just describing broad patterns in terms of differences in life expectancy across different subgroups of the population. And the method that you will learn in that context is what's called survival analysis or hazard models, which is a useful way to describe data when things are elapsing over time. And the key reference that we'll be focused on your syllabus is this paper published in the Journal of the American Medical Association a couple of years ago. Second, we'll talk about economics applications, so basically health economics issues, focusing on a couple of different sets of programs. The impact of food stamps policies, where on Thursday we'll have a guest lecture by Jesse Shapiro from Brown, who's done a lot of interesting work on that topic. And then we'll talk about health insurance programs. So in particular, when you expand health insurance, what happens to people's outcomes, what happens to the amount they're spending, to their health outcomes, and so forth, which is kind of a core focus, as you can imagine, of health economics. And there we'll talk about methods that are going to be somewhat familiar to you, hopefully regression discontinuity and other standard quasi-experimental methods. And then third, we'll talk about epidemiology approaches to thinking about these issues with modern data. And in particular, the application I'll focus on is using big data to forecast pandemics. And there, the method we'll talk about, which will be new relative to things we've talked about in the past, is predictive modeling. So how do you predict what's going to happen in the future given the data that you have on hand? And we'll talk about some nice work that's been done recently on detecting flu epidemics using Google search data. Okay, so I'm going to start today by just talking about broad population patterns descriptively on income and life expectancy. So the most common measure of health that people tend to study in the quantitative social sciences is just a very crude and simple measure, mortality rates. And so why do we look at mortality, kind of the final measure of health? Because it's extremely well measured in population data. So if you think about the way the US is structured, getting information on people's health over the course of their life, like let's say indicators like blood pressure or cholesterol or other things that you might want to collect, is very difficult because you rely on people going in to get certain types of tests. You also rely on disaggregated information from lots of different clinics or health insurance providers and so forth. And while people are trying to make inroads on collecting that type of data, what is much easier to measure is simply when people die and who has died and who's alive. Why do we have good records on that? Because in order to administer government programs, for example, think about Social Security benefits, you need to have exact information on people's date of death. And so you have that information systematically collected by the government quite reliably for the entire population. And so we're going to begin with basic descriptive facts about life expectancy in America, where in this paper from 2016, we examined the relationship between life expectancy and income in particular, and then look at how that varies across areas and try to understand the determinants of health inequality and life expectancy more broadly. What we're doing here is using data on the entire US population from 1999 to 2013, using information from the tax records that we've talked about several times, now linked to data from the Social Security Administration on mortality, so that you have 1.4 billion observations over that period on people's incomes and basically when they die, all right? So, as I was just saying, mortality is measured using Social Security death records, income measured at the household level using tax returns, and as we've done in previous lectures, we're going to focus on percentile ranks in the household income distribution when we measure income. So rather than looking at things in terms of dollars, we're going to rank people in the national income distribution within their birth cohort, gender, and by year, accounting for the fact that incomes change over time. So we're basically going to look at this based on your position in the income distribution. Okay, so what is our goal? Our goal here is to estimate the expected age of death, conditional on an individual's income, say at age 40, controlling for differences in race and ethnicity. So there's prior work showing that there are significant differences by race and ethnicity in terms of life expectancy. Black Americans tend to live shorter lives than white Americans, and there's some debate in the literature about why that is. Could be because of differences in access to healthcare, could be differences, biological differences. There are a bunch of theories that have been put forth, and it's not totally resolved. But it is a fact that there are significant differences in life expectancy by race and ethnicity. So what we're going to do is kind of take that out of the picture and say controlling for race and ethnicity, or given, say among white individuals or among black individuals, how does life expectancy vary, okay? And so our goal, just to be very precise on what we're trying to do, is take a set of people, say at age 40, measure their incomes, and ask how long will people expect to live given current mortality rates. So why age 40? Part of this is data constraints. You could measure income at earlier ages, you could measure income at later ages. Kind of what we're going for is if we measure income in the middle of your life, sort of around peak earnings, something like that, what does life expectancy look like from that point onward? If you measure income too late, like if you were to wait till the 60s or 70s, you're getting a very different picture in terms of what's going on, right? What we're trying to understand here is relative to sort of your lifetime resources, how does health vary? Okay, so specifically what we're going to measure is a concept, what's known in this literature as period life expectancy. This is the standard way to measure life expectancy. And so the idea here, what you might think of initially is I'm going to take a person at age 40 and follow that person forward, until they're 90 or 100 years old and just track mortality rates for a given set of people starting at age 40 and just see how long they live on average. So if you think about the type of data that you would need to do that, you would need data that spans many, many decades, right, in order to be able to follow people starting at age 40 up to age 100 or something like that. So you'd need data for 50, 60 years, which we don't have at present. And moreover, the kind of concept you would get there would be a little bit difficult to think about because it would incorporate both how things progress at a given point in time for a given individual, and any technological change that's occurring over that 50 or 60 year period that is changing mortality rates. So instead, what people do, which is both more feasible in the data and a little bit clearer to think about, is measure mortality rates within a given year. So let's say you take the data for 2010, measure the fraction of people who die at age 40, 41, 42, 43, okay? So you have this sequence of mortality rates. And you ask, what is the life expectancy for a hypothetical individual who experiences that sequence of mortality rates at each age within a given year? So this is not the actual experience a given person is going to have, because you are going to progress through time. And as you get older, technology is going to improve and mortality rates are going to fall at all ages. But if you take, imagine an individual hypothetically who experiences the full sequence of mortality rates by age in 2010, the period life expectancy measure is basically summarizing how long would we expect such a hypothetical individual to live. So it's a way of summarizing what do mortality rates look like at a given point in time, holding technology fixed. Okay, so that's what we're going to be doing here, and that's kind of the standard approach that people take. So how do we actually calculate this? This is going to be the methodology part of this lecture. So we're going to do this in 3 steps. First, we have to actually have the inputs that I just described. We're going to calculate mortality rates by income percentile rank and age for the ages that we're able to observe in the data. Now, we only have data over about a 15-year period, so we're not going to be able to get to much older ages. And so this is where the statistical model is going to come in. We're going to estimate what's called a survival model to basically extrapolate mortality rates out to older ages, and you'll see how that works in a second. And then finally, in the 3rd step, which I'm not going to go into detail on in this lecture, we're going to adjust for racial differences in mortality rates. You can basically think of this as like a reweighting exercise. We talked about propensity score reweighting in an early lecture. So think of this as basically adjusting for racial composition so that we have an equal number of blacks, whites, Hispanics, and Asians within each income group. That's essentially what we're doing in that final step. Okay, so how does this work? I'm going to just walk you through a diagram that will hopefully make the ideas very simple and clear. So what we're doing here is taking a set of men who are at the 5th percentile of the income distribution, so relatively low income, at age 40, and we're tracking what fraction of them are still alive at various ages, hence the term survival curve. What fraction of people survive as we look through time, all right? And you can see that it starts out by construction mechanically at 100%, so everyone's alive in this group that we're looking at age 40 when we're measuring their incomes. And then we see as people start to die, the survival rate falls, such that by the time you get to age 76, you have something like 50% of men who were at the 5th percentile of the income distribution are still alive at age 76, okay? Now, in the data that we have, we're not able to look past age 76. If you just think about the number of years we have, 15 years of data, and we're measuring income kind of between age 40 and 50, you're not able to go beyond this point. Okay, so that's kind of the technical problem that brings in the need to have a statistical model. Okay, so that's the data for men at the 5th percentile up to age 76. Now we can contrast that, and you can start to get a flavor for how these patterns look by looking at the same survival curve for men who were at the 95th percentile, relatively high income, at age 40. And you can see that survival curve looks very different. At age 76, more than 80% of men who were at the 95th percentile of the income distribution in their 40s are still alive. Okay, so that immediately tells you a finding that we're going to establish more systematically, which is that life expectancy and mortality rates vary quite substantially with income in the United States. Okay, so now we want to be able to go beyond age 76 in order to be able to estimate life expectancy. And so how are we going to do that? We need estimates of mortality rates beyond age 76, right? And so it turns out there's this really strikingly stable statistical relationship which was documented by an actuary named Gompertz back in 1825, nearly 200 years ago. That is an incredible statistical pattern that has really stood the test of time. And so he documented that mortality rates grow exponentially with age. So in particular, you can describe the mortality rate at a given age A, M of A, as a constant K times e to the power beta alpha, beta A, where A is your age, okay? So in other words, if I tell you your age A, and I know these two numbers, K and beta, which I can estimate in the data, I'll show you how we do that in a second, I can almost perfectly predict mortality rates at each age. Okay, so a different way to say that is if you just take logs of that equation, it says that the log of the mortality rate is well described by a straight line. It can be written as kappa plus beta alpha, okay? And so Gompertz documented this in a small sample of Swedish data back in 1825, and people have looked at this relationship in many, many different samples over the years, and in fact, even in other species, and it turns out this is a very, very strong systematic pattern. So to show you what that looks like in the US population data, what we're plotting here is the log of the mortality rate on the y-axis, okay? So just take the mortality rates that you estimated each age that I was showing you before and take the natural log of that. Okay, so that's what's on the y-axis. On the x-axis is age. And you can see that this looks almost perfectly like a straight line, right? So there's no reason that it had to turn out this way. This thing could have had any shape you would want it in principle. But it turns out, as an incredibly stable fact, that in the US population data and more generally, you find that this is almost perfectly approximated by a line, which is exactly that equation on the previous slide, that log mortality rates are approximately linear in age. There's a little bit of deviation. As you can see, there's a little bit of curvature from that line after age 90. So that's a well-documented phenomenon that after age 90, there's a little bit of deviation from what's called the Gompertz model. But up to age 90, the thing looks basically like a straight line. So this is in the full population for men and women. This also happens to hold, as we show in this paper, at each income level. So if you look at mortality rates for men at the 5th percentile and men at the 95th percentile, mortality rates are going up as you get older. So the well-known fact, right? As you get older, in any given year, probability of death rises. Mortality rates rise more steeply with age for men at the 95th percentile, who have much lower mortality rates in the red when they're young than men who are low income. But importantly, and this is, I think, the striking statistical pattern, both of those relationships, again, look almost like a perfect straight line. And so what that allows you to do is basically what we've shown here by fitting, all we're doing here is just taking the best fit line, and then you can trace that out past age 76. So even though we don't have the data after age 76, you can see that you can make a pretty good guess about what mortality rates are going to be after age 76 using this survival model, using this statistical model. You basically find the best fit line and extrapolate it out. And how do you know that's going to work pretty well? Because, just look at it visually. If we only had the data up to age 60 and we had fit that best fit line and predicted what mortality rates would be at age 70 or 75, we'd be pretty close, right? So this looks like a pretty good statistical model. And so following that logic, essentially what we're going to do is fit what I showed you on the previous slide, and just that allows us to trace out the survival curve shown in the green and the orange here beyond the ages where we actually have that mortality rate data. So is that clear? Any questions on how that works? Yeah. Here. What is this? So yeah, so this is mechanically, what we're doing is we compute the mortality rate at each age, right? and then we're taking the natural log of that. So it's just a transformation of the mortality rate. And the reason, we could just plot mortality rates directly, right? But what I want to show you here is that the log of the mortality rate is linearly related to age. And so when I take the log, it's easy to see that this looks like a straight line. If I didn't take the log, it would have an exponential shape. And so then it's harder to see, exponential curve fits the data. So it's just a transformation to make that point clear. Does that make sense? Anybody else? Yeah.
If there's such a steady relationship and it's so easy to predict outcomes with data from, say, 40 to 60, then doesn't that suggest that healthcare benefits like Medicare or financial Social Security that only kick in at a very late age have really next to no impact?
Yeah, good question. So I skipped over that, but let me just make that point now because you bring it up. So you see that exactly here, right? So age 65, you become eligible for Medicare, right? And exactly as you note, you don't see any significant break in terms of the pattern mortality rates, right? So suppose you thought, and I'm going to come back to this in more detail, suppose you thought these differences were fundamentally driven by differences in healthcare access. So what happens in the US at age 65? You basically have universal healthcare after that point, right? There are gaps in healthcare coverage by income before age 65. If you thought it was literally about access to healthcare or health insurance coverage at a given point in time, you would expect this curve to break differently for the low-income men relative to the high-income men after age 65. And exactly as you noticed, you don't see that. And so that suggests that at least healthcare coverage in terms of having an impact at a contemporaneous point in time doesn't seem like what's going on. It could be that healthcare coverage kind of building up from much earlier ages, it's kind of through an accumulation effect is leading people down different paths. But it doesn't look like if I, for instance, change the Medicare eligibility threshold by 1 year, that's going to dramatically change mortality rates. So, yeah, exactly right. Okay. So we trace out this curve to later ages. Now, I pointed out that after you get to age 90 or so, we think this extrapolation doesn't work that well. So we're going to do something much simpler after that point. We're going to just take national data on mortality rates after age 90. This is not hugely important anyway because there's not a lot of mass out there past age 90 in terms of the set of people who are dying after that point. And so we're just going to take data from the National Center on Healthcare Statistics and SSA of just estimates of mortality rates at much older ages, which they've constructed for the entire US population, and just plug those in to fill in the rest of the survival curve. Okay, so what we've done here, just to summarize, is built this survival curve starting at age 40 all the way now out to age 100 that gives you what we think are decently reliable estimates of mortality rates by income, by age. And so now what you can do using those survival curves is construct estimates of life expectancy, which is just the average length of life for a given person given all these mortality rates. You can show mathematically that actually just corresponds to the area under these survival curves. It turns out that's exactly what it matches, but think of it as just taking all that data and computing the average value, like what's the expected point at which people are going to die based on their income. Okay, so what I'm going to do is summarize what you get first at a national level, and then we're going to zoom in to look at this data by locality. So before I do that, I want to just gauge people's sense of what these data look like by asking you the following things. So the poorest men in America, think about people in the bottom 1% of the income distribution. They have life expectancy computed in this way, comparable to average life expectancy in which of these countries do you think? And you can fill in the poll. China, the Dominican Republic, Greece, or Sudan. So take a minute and see what you guys think. Okay. So quite a bit of support for the Dominican Republic and Sudan. So you guys are fairly pessimistic about, at least some of you, about life expectancy for low-income men in the US. All right, so let's turn to see what the data actually look like. So here's expected age of death versus household income for men at age 40. So you can see, as we kind of guessed from what I was showing you before, that this is upward sloping. And there's a really big gap here, right? So differences in life expectancy ranges from below 75 years, something like 72 years for men at the bottom of the income distribution, up to something like 87 years for men at the top of the income distribution. So that's a gap of about 15 years, right? So an enormous difference in life expectancy by income for men in the US. And construct the same curve, so sorry, before I show that, so now how does that fall in the international distribution? So this is now just showing you average life expectancy across all countries, right, in the gray lines, and then we're pulling out selected percentiles for men in the United States. And so, the richest men in the US have life expectancy that's higher than average life expectancy in any country in the world. If you take the lowest income men in the US, the bottom percentile, P1, it's in fact fairly close to Sudan. That's the answer. So you see very low levels of life expectancy, between Sudan and Pakistan for the lowest income men in the United States. So within the US, you have a spectrum of health outcomes that ranges in some sense from what you see in relatively poor developing countries to the richest countries in the world. Okay, so tremendous amount of health inequality. Now you do the same analysis for women and you get this curve in red. So again, you see a quite significant gradient, but I think there are a couple of interesting differences. So first, the gap in life expectancy between the bottom and the top for women is noticeably smaller. It's more like 10 years rather than 15 years. And the second thing you see, as I'm sure you all know, women tend to live longer on average than men. That's a well-established fact for a long time. But that gap in life expectancy by gender is much larger at the bottom of the income distribution than at the top of the income distribution, which I think is not obvious in the past. So it's actually kind of interesting. Near the very top of the income distribution, you almost have a convergence where there's only something like a 1 or 1.5 year gap in life expectancy between men and women. But at the bottom, you have this enormous gap that opens up. And so in particular, low-income men have extremely high mortality rates in their 40s, 50s, and 60s relative to higher income men. Why is that the case? I don't think we know for sure yet, but it's consistent with other evidence we've talked about in this class where you tend to see more adverse outcomes, especially for men, in the face of poverty and resource deprivation. It could be partly a biological phenomenon. There's a bunch of work recently arguing that men tend to be less resilient in the face of adversity than women. It could be about other environmental factors and so forth. Okay, so those are the broad national patterns kind of at a snapshot in time. What I want to turn to next is how these patterns are changing over time. So we all expect that over time, life expectancy is going up, health is getting better. That's kind of has traditionally been the case for many, many years. What do those trends look like by income group? So what we're doing here is now taking those estimates of life expectancy in each year. So this is where the thing that I was describing at the beginning on the technical definition of life expectancy, that it's a period measure using data only within a given year for people of different ages. This is where that really becomes important. So just to understand what we're doing here precisely, let's say you take the blue dot on the far left, okay? That's for people in the bottom 25% of the income distribution, the first quartile. We're taking the data on their mortality rates from 2001, and we're constructing an estimate of life expectancy just using that data in 2001. Then similarly, we construct an estimate of life expectancy just using the data in 2002, 2003, and so forth. So what you can see is that life expectancy is going up over time for all of these groups, but it's going up much more rapidly for people at the top of the income distribution than it is for people at the bottom of the income distribution. So the average change in life expectancy is about 0.08 years per year for people at the bottom of the income distribution. And it's about 0.2 years per year for people at the top of the income distribution. So what that means is over the past 15 years or so, when we're analyzing these data, there's been about a 3-year increase in life expectancy for high-income Americans. And there's been something more like a 1-year increase in life expectancy for low-income Americans. And if you zoom in at the very bottom of the income distribution, like the bottom 5%, you find essentially no progress at all over the past 15 years. So you should not think of kind of medical technology as improving and everyone's kind of gaining uniformly as a result of that. No, it's actually very unequally distributed gains in terms of health, right? For women, you see a very similar pattern, if anything slightly accentuated, where at the top of the income distribution for women, you see significantly larger gains in life expectancy than at the bottom, right? Questions on this? Okay, so what I want to turn to next is to ask what is driving these differences in life expectancy across the income distribution, which is, of course, the question that people care a lot about. And as an angle to get into that, I'm first going to break this national data up across local areas, because we're going to be able to learn from that, looking at differences across places within the United States, as we've done in other contexts, like looking at the geography of upward income mobility and so forth. So start with this chart, which just shows you the same life expectancy statistics, expected age at death versus household income for men in selected cities in the United States, to illustrate a broader pattern that we see. So picking people in 4 cities, New York City, San Francisco, Dallas, and Detroit, same kind of chart that I put up before, constructed in the same way. And you see, I think, a striking pattern, which is if you're rich, it doesn't matter a whole lot where you're living. Your life expectancy is pretty similar, and it's quite high. But if you're poor, there's quite a bit of variation in life expectancy across places. So in New York City, low-income men live on average about 6 years longer or 7 years longer than low-income men in Detroit. To give you a benchmark to think about that 6 or 7 year figure, I find it's useful to think about this comparison. So the CDC estimates that if we were to eliminate cancer as a cause of death in the US, average life expectancy would increase by 3.2 years. Okay, so relative to that 3.2 year benchmark, the effect of eliminating cancer, 6 year difference between Detroit and New York City is huge, right? It's beyond as if, in one city, people are kind of immune from cancer, in another city they're not. It's actually twice as large as that difference. So there are quite substantial differences in life expectancy across places at the bottom. That is, I think, particularly evident for women. So if you look at women, I think this is quite striking. If you look at the pattern that you see for women in New York City and San Francisco, that relationship is almost flat for a lot of the income distribution. So that's remarkable, given that in the US as a whole, there's this incredibly steep gradient of health with respect to income. But in certain cities for women, you can be a low-income woman in New York City and have almost the same life expectancy as an upper middle class woman. In Detroit, you can see that that's not the case. And one thing, again, I should note is all of this is being adjusted for differences in race and ethnicity in the background. So you might be thinking, is the difference that we're seeing in Detroit driven by the fact that there's a larger African-American population there or something like that? That's not what is driving this, because we're holding racial composition fixed as we're making all of these comparisons in the background, right? So now, generalizing beyond those 4 examples, construct this map of life expectancy across commuting zones, across areas in the US, where dark red colors represent areas with lower levels of life expectancy, and the yellow colors are areas with higher levels of life expectancy. And you can see that the lowest levels of life expectancy are concentrated kind of in the Rust Belt, industrial Midwest, and then going south from that area among low-income individuals. You also see other sharp contrasts. So for example, if you look at Nevada versus Utah, you see very sharp differences in life expectancy between those two states. That's actually a fact that's been noted a long time ago by a well-known health economist named Vic Fuchs, who has a book specifically comparing health outcomes in Nevada and Utah. And I'm going to come back to explain what we think might be going on there. So if you look at this pattern, I think one thing that's kind of interesting, maybe surprising about this, is that you might have thought that you'd see the lowest levels of health and life expectancy in the Southeast, which is what I think a lot of people expected before we put out this study. And so to understand why you don't actually see that pattern, it's important to note that what we're showing you here is life expectancy among low-income people. If you instead do something else, which is construct a map of just life expectancy on average, pooling all income groups, so just take everybody in each place and just ask how long do they live on average. That's what this map shows. So here you see a pattern that I think people working on health issues find familiar, which is you see the lowest levels of life expectancy in the Southeast, right? In places like Louisiana, Alabama, and so forth, those are in the reddest colors. But if you go back up here to life expectancy among low-income people, Louisiana actually looks relatively above average. So what is going on there? What this comparison tells you is levels of income tend to be relatively low in the Southeast, right? So Louisiana and Alabama have a lot more low-income people than, say, Massachusetts or, California, right? And so that's why we already saw at the beginning that income is very strongly associated with life expectancy. And so when you have a larger concentration of low-income people, you end up with lower levels of life expectancy. That's what this chart is showing you. But what this chart's showing you is controlling for income among low-income people. It's not like health in Louisiana is exceptionally poor, right? In fact, it might be slightly above average. And so I think that's important because it suggests that some of the poor health outcomes that we're seeing in the Southeast might not be about health per se, but rather about income or a broader set of factors that are associated with low levels of income that are then associated with poor health outcomes as well, okay? And so that's what you learn, I think, by disaggregating the data and looking at it by income. Now, again, if you look at the pattern for women, I think you see that in an even starker way, where you see that conditional on income, actually much of the Southeast where people worry about these issues, you actually have higher levels of life expectancy if you're a poor woman in the Southeast than if you are, say, in the industrial Midwest, okay? And so again, that shows that the ability to control for income and look at these patterns across areas is extremely important. Okay, so naturally, you're probably wondering, what is it that's different about these places that have high versus low levels of life expectancy? So I'm going to turn to that in the last part of this lecture. Before I do that, we've been looking at the broad maps. Let me just show you now to give you one final sense of what these places are. Just take the biggest cities in the US. What are the places with the highest levels of life expectancy and the lowest levels of life expectancy for low-income Americans? And you can see the places at the top are New York, much of California, parts of Florida. And then if you look at the bottom, it's places like we were seeing on the map concentrated in the Midwest, like Gary, Indiana, Indianapolis, Las Vegas, as I mentioned before, in Nevada, Detroit, and so on. So a quite different set of cities. In the left, to just roughly summarize, coastal cities that are quite affluent. On the right, more of the industrial Midwest. Now, importantly, all of these statistics are for people with low levels of income. You can also construct these statistics, obviously, for people with higher levels of income. As I showed you in that initial chart, there's not nearly as much variation in life expectancy across places for high-income Americans than low-income Americans, which is why we're focused on this part of the picture, okay? Because place really seems to matter, location really seems to matter at the bottom of the income distribution rather than the top. Okay, so the question that I'm gonna talk about in the remaining time is why are we seeing this variation across places, on the order of 3 or 4 years, the having cancer versus not having cancer level of variation. Okay, so the way we're going to look at this is first just correlationally using this local area variation to explore the determinants of life expectancy. So, you can correlate these measures of life expectancy with lots of different variables, as we've done in previous lectures with other outcomes, measures of segregation, income inequality, education, things like that. Here we're going to hone in on separating 2 classes of explanations. In particular, we're going to ask, is the lower life expectancy in some areas driven by a lack of access to healthcare, coming back to the Medicare type of question, or is it driven by differences in health behaviors? So is it kind of about, treatment and health insurance availability and things like that? Or is it about the choices that people are making in health behaviors? By that we mean things like decisions to smoke or diet or exercise. So, a very different potential set of determinants. And so the way we're going to do that as a first pass, I'm going to show you a couple different pieces of evidence, but going to start by just correlating life expectancy estimates with measures of healthcare access, like rates of health insurance coverage and so forth, and health behaviors in order to answer this question. Again, before I do that, it's useful to get a sense of what people's priors are on this. So which factor do you think is most predictive of differences in life expectancy for the poor across areas? Let me ask you guys to fill out this poll. All right, so I feel like I might have tipped my hand a bit by indicating that health behaviors are important. But regardless, lots of people think it's health behaviors. I would say, generally, a lot of people think that the fundamental thing here is access to healthcare. And so let me show you how this plays out in the data. So what we're going to do is correlate life expectancy for people in the bottom income quartile with a bunch of different variables that I'm going to list on the y-axis there. And then I'm going to show you just the correlation coefficient. The dot shows you the point estimate, and then the line shows you a 95% confidence interval for that estimate. Okay, so start with a few measures of health behaviors. So the fraction of people who are smokers among low-income individuals in an area, correlation of minus 0.7 with life expectancy, so an incredibly strong correlation. Obesity, minus 0.5, exercise rates, plus 0.3. So to give you a sense of how clear these patterns are, if you look at the pattern of smoking rates among low-income people in the US, just look at that map, red colors are higher rates of smoking, you can just see immediately visually that looks really similar to the maps that I was showing you before, right? And notice, in particular, the pattern that I was describing, that if you look at places like Louisiana or much of the Southeast, you actually have lower rates of smoking conditional on income than in places like Appalachia, where you have the darkest red colors and you also have the lowest life expectancy. So you see exactly mirroring what I talked about before. Similarly, look at Nevada versus Utah, exact same contrast that we saw in the context of life expectancy, right? So you can see why you get a correlation of 0.7 here. This looks incredibly similar. So I think obviously smoking has been shown to have a direct impact on health and life expectancy. That is part of what's going on, but you shouldn't interpret this as all of the difference is literally due to smoking, because it's not big enough to explain the magnitude of the variation that we're seeing. So the fraction of smokers, if you look at the scale, is going from 23% to 35%, something like that. So that obviously has some impact on life expectancy, but if you were to work out based on epidemiology estimates, how much does smoking cost you in terms of years of life, it's not a big enough effect to explain the 3-4 year gaps that we're seeing across places. So the way to think about it is more that it's a signal more broadly of health behaviors that might have adverse effects on people's health through various channels, okay? So clear, strong association with measures of health behaviors. So now let's turn to measures of healthcare access. So this is tricky, right? Because there are many different things you might mean by healthcare access. It's not totally obvious how you measure it. So some obvious things you can look at: what fraction of the people don't have health insurance in a given area? What are Medicare expenditures in an area per enrollee? So just kind of like a how much are people spending on health sort of measure. Then you can try to think about measures that are more related to quality of healthcare, which is probably what you want to measure. And so one commonly used measure is a hospital mortality rate index. So if you're admitted to the hospital, what fraction of people die within 30 days of admission is often used as kind of an indicator of, are you providing good quality healthcare once you're in a hospital? Adjusting for the conditions you came in with, we expect to see lower mortality rates if quality of care is good. And then another measure that people use is an index for preventive care. So for example, if you're diagnosed with diabetes, are you getting your eyes checked, or are you getting other sort of standard preventive care? And you can measure the extent to which that's happening in different areas. And broadly, what you see, as you can see from this chart with all of those measures, is there's not that much of an association. It's not actually the case that places with lower rates of health insurance coverage have significantly lower levels of life expectancy. In fact, there's not much of an association at all. Now, I want to emphasize that does not mean that healthcare access has no causal effect on life expectancy. At some level, it would be crazy to think that healthcare plays no role in life expectancy, because obviously, being able to go to a hospital to get healthcare when you need it is valuable. What this is telling you is that the differences across areas in levels of life expectancy is not readily attributed to those types of differences. And why might that be the case? If you are in dire need of medical care, you can go to an emergency room even if you don't have health insurance in the US, and effectively, they're obliged to give you care. That may not be the best way to do it. It may create financial hardship and lots of stress and various other things. But in terms of literally keeping you alive, perhaps that's not the key driver. At least that's what these correlational data seem to suggest. Okay, so it comes out pretty strongly in favor of the health behaviors view rather than the healthcare access view. Okay, so then you can look at a bunch of other things. Environmental factors like segregation, measures of inequality, social capital, measures of the strength of the economy, unemployment rates, and so forth. And all of that, as you can see here, there's some correlations, nothing nearly as strong as the health behaviors. My sense is nothing really pops out there. What does pop out is if you look at a different set of factors that basically measure how affluent and educated a place is, you find very strong correlations. So in particular, if you think back to the list of cities that I showed you, so you think about places like New York, Silicon Valley, and so forth, those are places with many immigrants, very high house values, high population density, a large fraction of college graduates. And you can see that it's not just those couple of places that fit that pattern. More broadly, if you correlate with these sorts of variables, you find quite strong correlations with life expectancy. So the basic pattern that you see in the data is that these affluent, highly educated cities, among low-income people, you see much better health outcomes. You see much better life expectancies, which is what we're showing you here, You also see much better health behaviors, so much lower rates of smoking, lower rates of obesity, higher rates of exercise, et cetera, among low-income individuals living in places like San Francisco and New York. So I think the interesting question to understand is, why does that happen? So is it because there's some causal effect of living in those cities? So to throw out some possible explanations, it could be that it's about peer effects. So if you're around a bunch of other people who are eating healthier, exercising, et cetera, maybe that influences what you choose to do. And then that changes your own health. So that's one story. Another story is more of a supply side story. So if you think about what types of products firms are offering, if you've got a huge base of people who are interested in buying healthy produce and fresh food and whatever else, as opposed to cigarettes, we're going to have a different supply of stores in a given area. And that might end up affecting what other groups in the population end up choosing to do, just because of what is available and what's cheap and what's accessible. A third possibility is that it's actually not about a causal effect of being in San Francisco or New York, and rather it's just about the types of low-income people who live in San Francisco and New York versus the types of low-income people who live in Gary, Indiana. So we don't know which of those explanations is at play. You could try to figure that out by doing the type of analysis we've done in other contexts, by looking at people who move across areas, for example. The work that's been done on movers in this area just looks at impacts on health immediately after the move. So there's some nice work by Amy Finkelstein at MIT showing that when people move to an area with higher mortality rates, the year after, they have somewhat different mortality rates themselves, but the effect is not huge. But if you think about what I think is the more likely mechanism here, it's probably something about exposure that accumulates over many years. So I don't think we expect that you move to San Francisco and next year your health is going to be totally different. But rather, if you're in San Francisco for many, many years, or maybe if you grew up there, you'd be on a totally different trajectory. And that type of analysis requires really long span of data where you can look at somebody who moved to San Francisco when they were 20. You can't look at mortality rates when people are in their 20s or 30s because they're super low. You need to wait till they're older, and just kind of getting that structure worked out, I think, has not quite been done yet. So we don't know exactly what the root causes are of these patterns, but it does seem like there are some pretty systematic differences across places in low-income people's health outcomes that seem to be channeled through differences in health behaviors. I think that's the key takeaway here. Questions on this? Yeah.
When you're looking at low-income people, is that based on a national sliding scale, or is it the bottom quartile in New York versus the bottom?
No, so it's the bottom quartile in the national distribution. So think of it as like at a fixed level of income below $25,000 or something like that is basically what it is. Yeah. Did you have in mind that it would be different if you were?
I'm just curious about the effect, because obviously the dollar would go a lot farther maybe in Gary, Indiana than
Yeah. But so that makes it all the more striking that you see this pattern, right? That you would think in New York, you might have actually thought it would go the other way. If you're earning $25,000 in New York, it would be worse in terms of stress and health than if you were earning $25,000 in Gary, Indiana. But in fact, you see that the person earning $25,000 in New York lives longer than the person earning $25,000 in Gary. So I actually think that amplifies, why this is a striking pattern. Yeah. Yeah.
So there's systematically less people earning like $25,000
Yeah.
than in Indiana.
Yep, absolutely. So of course incomes vary, right? Which is part of what we're seeing here. Like places like New York are more affluent. They have more rich people and fewer people at those low income levels. You'd worry about that if the sample was so small that there's hardly any data there. That is not the case because we're working with the entire population. So that's the advantage of having, the full population data. But absolutely, there are fewer low income people in some of these places than others. Yeah. Anybody else? Okay, so the last set of results I want to show kind of come at this from a slightly different angle and I think reinforce the messages that we've been talking about. So as I've been emphasizing, the local area variation seems to suggest that if you really want to have an impact on this problem, I think the national debate on things like universal access to healthcare and so forth can be quite important, especially when you think about things like financial hardship and other issues. But if you literally want to change health outcomes and life expectancy in particular, you really need to think about how you change health behaviors. And maybe the way you change health behaviors is actually ultimately through health care, through your doctor telling you to do more preventive stuff or to get you to exercise, change your diet, and so forth. But it's clear that the change seems to have to come through behavior. Now, further evidence for that view comes from directly examining nutritional patterns by income group. So there's some nice new work that's been done by Hunt Alcott and a group of other researchers where they use Nielsen home scan data on grocery store purchases to examine how nutrition varies with income. So the way this works is there are about 170,000 households in the US that participate in this survey or this kind of thing that Nielsen, which is a marketing company, has set up, where they scan all of the purchases that they make at any store when they come home and basically record the barcodes of what they've purchased. Okay, so this is a way for this firm to track what people are buying and which types of people are buying which products. So you can see why companies find this sort of data extremely valuable because it helps you market your products more effectively. So in this case, the researchers are using these data to study issues of health inequality. And in particular, they take those barcodes and match each of them, the stuff that you buy in grocery stores, to nutritional information that the USDA has constructed on things like sugar content, nutritional value, various measures of what people are basically consuming. And now you also have data on what people are consuming, but also what their incomes are, what their educational background is, where they are, so you can ask how do nutritional patterns vary across groups. And so what you see, I think, is a very clear pattern that's consistent with the kind of story that I'm telling here. So this is looking at the amount of added sugar that people consume based on what they're buying by their household income. And you can see that low-income Americans consume a lot more added sugar per 1,000 calories than high-income Americans. So less healthy choices on that dimension. You can look not just at sugar content, but a bunch of other things. Do you buy whole grain? To what extent are you buying produce? You can construct this broader health index that is, the USDA defines what are healthier foods, so fruits and vegetables versus more processed stuff, less fat, less sugar, et cetera. Aggregate that up into a health index, and these are standard deviation units on that last graph there, the health index graph. So basically, if you look at the highest income Americans versus the lowest income Americans, they're eating about half a standard deviation healthier foods than lower income Americans, which is a substantial shift in the distribution of nutritional quality. So it's very consistent with the idea that people are making different choices at different levels of the income distribution. Now, one thing you might be wondering about is whether those differences that I was showing you on the previous chart, are they truly about different choices that people are making or differences in access to the types of foods people have? So you might think, there's more fresh food available maybe in higher income markets, and maybe that's why high income people buy more fresh fruit, et cetera, relative to low income people. That's a pretty prominent hypothesis actually in the nutrition and health literature. The term that people use for it is this idea of food deserts, that maybe in certain low income neighborhoods, you can't actually get to a grocery store that sells at reasonable prices healthy food. And maybe it's because of literally a lack of access to healthy food that you see these big differences in nutritional patterns. So you can't tell, right, whether it's a preference story or an access story from the chart that I just put up before. But they do some further analysis that I think shows quite convincingly that this is not about differences in access. It's actually about differences in tastes. And so the way they do that is by repeating the charts that I just showed you. But now they basically control for the market that people are in. And so they do that in two different ways. So first, if you look at the upper two charts, they look at people who are in the same zip code. So remember, in this Nielsen data, you see where people are, right? And so you can look at a set of low-income and high-income people who are in the same zip code. So as a way to kind of control it at some level for, what are the set of grocery stores you could go to in your area, you can say, if this was really about different grocery stores in different places, I should see if I compare two people who are in the same zip code, maybe that gradient flattens. And what you can see is the blue dots are what I showed you in the previous chart for that health index. And then the red crosses, red X's, are once they control for being in the same zip code. They're taking out zip code effects, and they're basically comparing people within the same zip code there. And you can see that the red and the blue basically look the same as each other. So even when you compare people in the same zip code, low-income people are eating less healthy food than high-income people. You can then furthermore, on the right side, they're controlling for other demographics, beyond just the zip code you're in, you get a very similar pattern. Okay, so you might say, that's fine, but even within a zip code, maybe a higher income zip codes are fairly big. Higher income people are more likely to have a car, it's easier for them to commute, get to a certain grocery store, et cetera. For lower income people, maybe you're not really perfectly controlling for access. So then they do a second thing, which I think is quite convincing. They look at people who shop at the same chain, so they can see which grocery store you're going to. And now they're saying, let's literally take two people who go and shop at the same store and then do the same analysis. The red X's are comparing people who shop at the same store, high income versus low income. And again, you can see it flattens a little bit now. The red thing is a little bit flatter when you look at the lower two panels than the blue, but it's still like 90% of it is still there. So it really doesn't seem like this is about people having access to different stores. It really seems to be about different choices that people make when they're presented with a set of products to buy. Okay, questions on this analysis? Yeah. Yep. So I'm going to come to that in a second. So it could potentially be about just cost, and I'll come back to that. And actually, Jesse Shapiro's lecture on Thursday, looking at food stamps, which is effectively trying to deal with some of the cost issues, is going to get directly at your question. Others? Okay, they do one further analysis here, which I think additionally supports this view, which I'll just summarize briefly here in the interest of time. So they look at the entry of new grocery stores in a given market. So, a new chain opens in a given place that maybe had stocks healthier foods. Does that affect the choices that low-income people make? And they find that has essentially no impact. So again, that's kind of a direct test of the food desert hypothesis. If you have new grocery stores open in a given place, does that actually have an impact? And it doesn't. And the reason it doesn't is that when you look at where people shop, it's actually not super close to where they live. So this idea that you have to have a healthy grocery store within 0.5 miles of where you are, and that's going to have a huge effect, that doesn't really hold water, because a lot of the average American tends to shop, in a broader radius. And so the direct access hypothesis doesn't seem that plausible from that ground. Okay, so why am I spending time on this? I think this, again, in a different vein, kind of reinforces the point that I was making earlier, that differences in health outcomes across income groups don't appear to be caused by a direct lack of access to resources, right? Before I was making that point in the context of health insurance, and now in the context of access to high quality nutrition, really appears to be due to different choices made by lower income households. And so then the question becomes, exactly as you had raised, why do low income households tend to have less healthy behaviors? Behaviors themselves are the product of preferences and environment. It's not like they just happen at random. And so to lay out, two potential hypotheses, one hypothesis is that this is about the effects of environment and resources at earlier ages on people's preferences. So one nice paper that I like on this, which is more from a developing country context, but I think similar themes would apply here, is this paper by David Atkin, who's also at MIT, where he studies migrants in India, people who moved between different parts of India. And they're, just as a bit of background, very different nutritional patterns in different parts of the country. People tend to eat very different staples in different parts of the country. And he shows that the nutritional habits that you formed at young ages, whatever region you were in, if people ate more rice there or more grains there, that persists for many years, even after people move to a given city. And in particular, if you move to a place where the thing that you were used to eating as a kid is much more expensive, you actually consume fewer calories. So the preferences are so strong that you literally actually eat less because the thing that you're used to eating is now more expensive. And so, that's a piece of evidence that suggests that some of these patterns that we're seeing in the data, if when you were young in your household, lower income household, there wasn't a ton of fresh food or the habits were very different, maybe that then changes what you choose to do later on. And perhaps changing resources at that earlier stage, and perhaps even changing access to healthcare, would then shape the trajectory that people follow. That strikes me as one plausible hypothesis. As I was saying earlier, that's a hard hypothesis to test, and it's something that would take much more time to change. It would be nice if the answer here was, we need to give people more access to healthcare, and we're going to see an impact immediately. But it really doesn't look that way in the data. But that potentially, that's the way this plays out in the longer run. An alternative hypothesis, which is the one that you raised, is that maybe this is just about a lack of income that constrains choice. As you were suggesting, unhealthy foods may be less expensive per calorie. So if you're literally trying to just buy calories in some sense, you may be tilted towards less healthy choices. So that is a plausible hypothesis. It's part of the rationale for the big food stamps program that we have in the United States that tries to provide supplementary assistance for low-income households precisely to buy food. One rationale for that is just to support food expenditures. Another rationale could be to support healthier nutritional choices. And so what we're going to do in the next lecture, Jesse Shapiro, who's focused on this topic and is an outstanding researcher, is going to present his work that tries to directly test the impacts of food stamps on what people buy and on nutritional choices. So I think this is a good point to stop this lecture, and we'll pick up with that.